So on As You Learn, let me put ours up there. What you need to get on the final to get the grade you want is right here. The final's worth 100 points, 50 for the in-class, 50 for the take-home. You put the grade you want. And in the syllabus, it breaks down the A minus A, B minus B, B plus. It's in the syllabus. But you can even put 90 for an A. And your current grade goes here. You calculate it, multiply by 100, and that's what you need on the final. Under attendance and homework, there is I think 2 or 3. Yeah, 3 attendance problems. One is what day is your final? Another one is when does the take-home portion of the final need to be done? And I think the other one is when can you, what date do you have to have late homework turned in by? And all of that is right here, I think. The in-person portion of the final is Wednesday, May 10th at 8 a.m. till 10:30. The take-home portion is due May 11th, 11:59 p.m. And any late material, including projects, is due by May 11th, 11:59 p.m. so I can get them graded. So this is all the answers to your attendance for this week. The take-home portion is here. The in-class portion is here, but you can't get into it because you need my password, which you will get on Wednesday, May 10th when you get on Zoom. Any questions on that? The outline that we're going to go over for the in-class portion of the exam is right here. Any questions? It looks like this. There's 8 questions, and they resemble these. Is there any questions? I thought it's best to go over this first, and you can look at the take home, and then Tuesday and Wednesday, this might take a little longer than just today, but whatever time we have left on Tuesday and all of Wednesday, I'll take any questions on the take home. So make sure you try the take home sometime today so you know where you have questions. Number 11. It's on this page. There it is. Now the question asked, I don't remember what it asked you to do, but this is a nice one for a histogram. Although the numbers aren't in order. Well, that's going to be a pain. Okay. When you're finding a histogram, to find the number of bars, it's the square root of n. N is your sample size. So to find the number of bars, you should use square root n. N is your sample size. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 40. Then you take the square root of 40. I rounded. Now you want to use an integer. You're not going to have part of a bar. 6 or 7. It's better to use the higher value. So round up. If it comes out an exact integer, then you use that integer. But if you have a decimal, round up. For the units, it's your range divided by number of bars. Does anyone remember how to find the range? Your range is your largest minus your smallest. So our bars is 7. Largest and smallest. Got a 45. 45, 47. Does anyone see anything larger? I don't. Is everyone finding 47 as the largest? Here's a 31 for the smallest. $28. I think 28's the smallest. Is that what everyone's finding? Should have picked one in order. Okay, so we have 47 minus 28 divided by 7. So again, we're getting a decimal. Always round up on these ones. So this is 7 and this is 3. 3 is the units we're going to count by. Any questions on that part? So you start with your smallest, and you count by 3s. The smallest one was 28. 28, 31, 34, 37, 40. So I'm counting by 3 because that's what this is. 31, 34, 37, 40, 43. Did it go up to 47? Okay, so I need 46, 49. So you want to make sure you have your smallest and it fits into your largest. Any questions on that? Now for the first bar, we go from 28 up to, but not including 31. So we want to find all of them that are 28 up to, but not including 31. So 28, 31. Oh, let me write these all down real quick. It's easier if you can cross them out. On the test, it'll be a lot smaller. One, two, three, four, five. 1, 2, 3, 4. Okay. So what we need to do, it's 28 up to, but not including 31. 31 goes into the next one. 28 to 30. 1. This 31 goes in the next bar. So I think I only found one. So 1 would be here. Now this is 31 up to, but not including 34. Now, since we have integers, then it'd be 31, 32, and 33. 32, 1, 2, 31, 32, and 33. Three of them. Hopefully I got them all. The next one's 34, 35, and 36. 35. I already used that. 34, 5, and 6. One, two, three, 4, 5, 6, 7, 8. Next one, 37, 38, and 39, because 40 goes into the next bar. So remember, whatever numbers here is in the following one. 37 up to, but not including 40, which means 37, 38, and 39. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Probably didn't need them all. 10, 12, 14. Any questions on that? 40, 41, and 42. Of course, there's a and we're looking 41, 40, 41, and 42. 40, 40, 41. One, two, 3, 4, 5, 6, 7, 8, 9, 10. $43, $44, and $45. 3, 2, that goes in the other one. 3. And then 47 goes here. Any questions on that? The biggest thing you need to be careful of is the number. When you look at a bar, the number on the right is not in that bar. It's in the next one. So if you're looking at just one bar, the number 28 is in that bar, but the number 31 is in the next one. Any questions on it? So you'll have to do a histogram. It's not this big, it's a lot smaller. And the numbers are in order. It wasn't that it was big, it was just they weren't in order. But any questions on it? Find mean, median, mode, and range. And I chose number 6 because it wasn't real big when you're talking about finding the mean. There it is. Oh, on the histogram, make sure you label it. This was temperatures, I think. Yeah. So this is afternoon temps. And going up would be the frequency. It's how often those temperatures come up. Any question? So number 6. So we have these values and we want to find mean, median, mode, and range. Now, some of them we need to have them in a numerical value, so I'm going to put them in order. 3 is the smallest, and then 6, 14, 12, 12, and then a 14 and 2 15s. A 25, 17, 18. 20, 25. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 8, 9, 10. Okay, got them all. We want to find mean, median, mode, and range. How do you find the mean? Anyone? No. Add all of them up and divide by how many there are. So we add up how many, add them all up and divide by how many there are. And I believe there was 11. 4, 5, 6, 7, 8, 9, 10. Double check. And then you add them up. So for mean, they did not have to be in order. 3 plus 6 plus. The middle is your median. So for mean, we add them all up, divide by how many there are, and we get 12.27. Rule of thumb, go 1 decimal place more than your data if you're going to round, so it'd be 12.3. Median, middle value. There was 11, take off 1 and you get 10. So you can go 11 minus 1 equals 10. 10 divided by 2 is 5. There's going to be 5 on each side and the 1 in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the median is 15. Any questions on that? If there's an even number, 1, 2, 3, 4, 5, 6, 7, 8. So if there was this instead, to find the median, because there's 8, you add the 2 middle ones together and divide by 2. So when there's an even number, you take the 2 middle, add them together and divide by 2. What you're doing is finding the middle between them. Any questions on median? Mode is most often the largest frequency. Notice MD for median, MD for middle, MO for most, and mode. We'll look at the values. I'll go right here. I put them in order. which one repeats the most. 15's there twice. It's the only one. So the mode is 15. If none of them repeat, there's none. If there were also two 20s, then it would be both 15 and 20. So the mode can have no answers, more than one answer, or only one. Any questions on that? Passive. Mean, median, mode, I think it's a range, yeah. And we just did range when we did the histogram. But range is largest minus smallest. 45 minus 3 is 42. It shows you how far apart they spread. Any questions on that? So remember, if they're not in order, put them in order. For the median. The other ones you don't have to, but mode's a lot easier if it's in order, because then you have the ones that are repeating together. Any questions? Independent and dependent events. $330 million. Okay, so 32 starts at the bottom. I thought it was down there. There's 3. Number 32 and 33, because the one is independent, the other one's dependent. That way you could see both. Consider a standard deck of 52 playing cards. A card is randomly drawn, the card is replaced, shuffled, and the second card is drawn. Event A, first card is face card. Event B, second is, so is a face card. So both of them are face cards. Are the events independent or not? So are they independent or dependent? We picked a card, we put it back, we shuffled it, and we put it back again for the last one in my book. Let me look. It is a 17. I wrote it wrong. I saw the 27s, I think. This should be a 7. So then 17, thank you. Yeah, I even have it. So show all of your work. If you had this and then wrote this wrong, I know you knew what you were doing. You just typed something in wrong. Or wrote it wrong. I typed it in right. But any questions on them? So for number 32, we're pulling a card, we're putting it back in, shuffling it, and pulling another card. We want to know if that's independent or dependent. What you want to think about is, I have certain probabilities when I pull this card. When I pull this one, is what happened here changing my probabilities? So if I pull the first card and I put it back, when I pull the first card, I have 52 cards. I pull it out, I have 51. But I'm putting it back in, I'm reshuffling the cards. My probability stayed the same then because I still have the 52 cards. So the second one did not depend on the first, which means this one was independent. So since we shuffled, we put the card back in, we shuffled it up, it did not change the probabilities of the second draw. Any questions on that? Okay, let's find the probability of it. Well, think about, we know there's 52 cards. So in the first one, we have 52 cards. How many of those are face cards? A jack, a queen, and a king. And if you want, well, I don't know if I have cards. I know I have stuff similar. But you could have a deck of cards opened up, like on the screen. So with 52 cards, there will not be a joker. But there's 3, 6, 9, 12 face cards. So there's 12 face cards. The probability that the first one is a face card is 12 out of 52. Right now, before we put it back, we only have 11 face cards in the deck and 51 cards. But we're putting it back in, so our probabilities aren't changing. The probability of the second one is a face card is also 12 out of the 52. $27.04. If it doesn't specify, it's up to you if you want to use the fraction, the decimal, or the percent. Are there any questions on that part? Let's look at 33. Revisit the exercise and suppose that after the first card, after you draw the card, it is not replaced. Are events A and B independent or not? if we don't put that card in, we're changing our probability. So instead of being independent, it's dependent. The second card depends on what happened with the first one. Since the first card is not replaced, the probabilities of the second draw have changed. So the probability that they are both face cards, well, we know when we pull the first one, there's 12 out of 52. And that means we're taking one of these face cards out. Let's just assume it's the one the arrow's on, so we can tell we ignored that one. Now, if we take that King of Clubs out, there's only 51 cards there. And 3, 6, 9, 10, 11. 11 of them are face cards. Once we pull out a face card, we said there was only 11 face cards and 51 cards then, because we didn't put the one we pulled back in. It changed our probabilities, which means it's dependent. The second one depends on what happened first. And multiplying across 121 over the 2704. Any questions on that? Positive? Probability if an American is chosen at random, they are from North Carolina. Now, of course, you can look these up, but remember the values you should have an estimate for is the number of Americans and the population of the world. But if you had to look it up, I mean, I can't stop you. I mean, I wouldn't know, I guess. So we'll look it up. We want to know the probability if an American is chosen at random, they are from North Carolina. So let's do population of the US. 326.7 million. So 330 million. $10.5 million. Okay. So if we want the probability, if an American is chosen at random, that they are from North Carolina, what do we need to do? divide them. Remember, probability is how many your total is in the denominator, and then how many possibilities there are for your choice, in this case, North Carolina. So you would take the number of people in North Carolina and divide by the population. We had one similar to this in our attendance problems. It was if you chose someone from the world, what's the population they were American? Another number you should know, population of the world. Somewhere around 7.8 billion. 7.5 to 8 billion is a good estimate. So these two you probably want on your formula sheet. But if you had to look them up or something like this, that's fine. 10.5 million. 330 million. If these are the same units, you can just cancel the units. If they're not, put all the zeros in. So 10.5 million divided. Hit the wrong button. 10.5 million divided by 330 million. Oh, I guess it's not rounded. Written like this, it's not rounded. It doesn't say fraction, decimal, or percent. I'm going to use a percent. But you could use the fraction, the decimal, or the percent. Any questions on that? Find the complement of number 4. How do you find the complement? What is the complement? The complement is everybody else. If this is the probability a person chosen at random, they're from North Carolina, the complement is probability American is chosen at random. They are not from North Carolina. So the complement is the opposite. It's everything else. If 3.2% are from North Carolina, the rest are not. Now you can subtract this from 100 or subtract this from 1. 1 minus 0.03. I'm just going to use the 2. Three 3.2% of Americans are from North Carolina. 96.8% of Americans are not from North Carolina. So the complement is just 1 minus the other. Any questions on that? We don't have enough time to do box number 6, so we'll start there on tomorrow. So we'll finish these 3 tomorrow, and then I'll start taking any questions on the take-home portion. Any questions on that?